Isn't this just where you find like a common thing and you divide it?
Something like that. Okay. So 1, we need to remember all the different ways we can factor. GCF, difference of squares. Those only work if you have 2 terms. Your trinomials, you can call it the basic trinomial, but that's your a equals 1. This does not say this. It says a does not equal 1. So your 2 types of trinomials or grouping, so you'll either be given 4 terms, or when we're doing a does not equal 1, we'll be using grouping. So one of those methods. So with number 1,
That would be basic.
always check for a GCF first. Remember that that's, what do these have in common? 7 and 3. 7 and b. So we can divide out 7b. Remember that we are dividing, but we're still putting it out in front. Correct. And then we're seeing what is left when we divide out 7b. So if we divide 28a squared b by 7b, what's left? 4a squared. And then this would just be 9. Then we have to look and make sure that we cannot factor this anymore. So we have 2 terms. Can we use GCF here? No. What about difference of squares? No. Are 4a squared and 9 perfect squares? Yes. So we can use difference of squares. So we're going to bring down our 7b. We're going to have 2 factors. What times what would give us 4a squared? 2a. 2a. So 2a is going to be our first term in both sets of factors. Minus 3 and plus 3. So what times what would give you 9, and then you put a minus and a plus in one of them, does not matter the order.
And that's our answer.
Because as I look at these, I cannot use GCF or difference of squares again. So that is completely factored. Kavita.
To check answer, we do 30 times 2a.
You can do it as variation of ways. You could either multiply these 2 together, then this, multiply these 2 together, then this, or any variation of that. I'm not going to check it on here, but you are more than welcome to.
On the test, how many parts?
2 objectives, you mean? 2. Factoring and dividing polynomials. Questions? I don't know the answer to that off the top of my head. I can find that out.
Wait, how is this different from the last lesson we did? What?
We're using graphs.
Which lesson are you referring to?
12.
9 was exponents. Exponents. Do we have any other questions on 1? For number 2.
What?
We have 3 terms, so that has to be a trinomial, one of those trinomial factoring methods. We do have a number that's in front of your square term, but again, look and see, does this have a GCF? Can I divide something out of all 3 of these? 3. Which would leave what? Now the inside is still a trinomial, but it no longer has a number in front of the square term. So now it is a equals 1 trinomial. So we're going to use the x. And we're looking for 2 numbers that multiply to be negative 10, but add to be 3. So think about your factors of 10. One of them has to be negative.
Oh,
I would say
Negative 5. 5 and negative 2.
3.
So we bring down the 3, and we can go directly into our factors. m plus 5, and m minus 2.
Does it matter what order they're in?
Just the 3 has to go in front. Besides that, the others don't matter. 11. Can we factor either of these again?
No.
No. So yes, that is it. So if the answer to that question is yes, I can either factor out a GCF or I can use difference of squares, then no, you're not
And
done.
then the way that you check this is you just distribute the 3.
You could do that, yes. Distribute the 3 to this first part and then to this, or distribute these two together and then to 3.
And how do you determine that you can
Difference of squares. If both terms are perfect squares and you're subtracting.
The what's on the inside, it would be like a trinomial or is it like a basic trinomial?
Those are the same thing.
Okay.
Basic trinomial, A equals 1 trinomial. Other questions on that?
Is the test gonna be on paper?
Yes.
Are we gonna use
For number 3, you have 4 terms. Which type of factoring would we use?
Grouping.
Grouping, because that's the only one that applies to 4. So we're going to split the middle and look for what did the first 2 have in common?
X squared?
X squared. So if we divide out x squared, what's left?
X plus
X plus 2, or
Y.
something, y. What could we divide out of the last 2?
4.
-4. -4, because this is negative. Circle that.
Miss, this is open notes, right?
Say that again.
This is open notes.
no, unit 12 is
Unit 12 is open.
that's the last one.
Wait, what unit are we on right now? What unit are we on right now?
This is 10.
Wait, what do we need 11 and 12?
If we
11 is all your quadratic stuff. 12 is direct and inverse variation, literal equations,
I
and
think it's gonna be the
linear
hardest.
transformations.
Easy.
We barely had any time to do it because we had SOLs.
Also,
It's just like the axis.
Yeah.
if we divide out -4, what's left?
Got it. X plus 2y.
So now we see that our insides are the same, so that becomes one of our factors, x plus 2y.
And then the other one was the x squared, -4.
Minus 4. Can we factor either of these again?
4.
No,
Or x squared.
but you can't.
This one, using difference of
Yeah.
squares. So this would stay the same, we would just bring that down, x plus 2y. If we're using difference of squares here, what would our 2 factors be?
X plus 2y.
X,
X minus 2y.
x, this is a 4.
X plus 2 or X plus
X
4?
plus 2, x minus 2.
That's our answer.
And that would be our final answer. We cannot factor any of those again.
So we just have to factor down the lowest two.
Looks like ugly. Okay.
It has to be completely factored, which is that.
So it has to be X squared and negative.
Not x squared per se, it could be any variable squared or something to an even power, because then you could divide it by 2, and a perfect square
So if it
number.
was 4 minus 4,
It would be, we're going to do one like that, so
How many questions are
I don't know that off the top of my head, but I can look later. Do you have any other questions on 3? For number 4, we have 3 terms, so it has to be one of the trinomials. Does this have a GCF?
No.
No. So that means this is your A does not equal 1 trinomial, where we first take 4 and -2 and multiply those together. And we're looking for 2 numbers that multiply to be that, but add to be 7.
8 and -1.
8 and -1. The closer those 2 numbers are, 1 is going to be 1 or -1 is going to be one of your factors.
where'd you get 7? Oh, 7's the middle one, right?
7 is the middle one, yeah. So then we're going to rewrite this trinomial into 4 terms. The first term stays the same, 4y squared. The middle term we're going to replace with these two, plus 8y minus 1y, or just minus y, and then minus 2. And then we're going to split the middle. What do the first two have in common? 4y. And if we divide that up, what's left? Plus 2. What can we divide out of the last two?
Negative.
Negative 1. And what would be left? What would your final factors be?
Wait, how did we get
Pause. Lily, because we divided 4y to both of these.
Okay.
What was your question?
How did we get plus 2 if it wouldn't it be plus 1?
Here.
That's negative 1?
Yeah. We're dividing negative 2 by
Oh,
negative 1.
dividing.
Correct. If it said 4y squared, then we could, but it does not. So that is our final answer. Do we have any questions on that?
I'm so confused.
Kayla, did you have a question?
No, why did you do it now? Yes.
Number 5. Do we have a GCF? 3W. You guys divide out 3W. What's left? Can this inside be factored again?
Yes.
Yes, using what?
Difference of squares.
Difference of squares.
4 and W2 and minus 1 plus 1.
4W squared minus 1 and 4W squared plus 1. Yes. What times what would give you 16? 4. You could either say what times what would give you W to the 4th or just cut it in half. W squared.
Wait, so one?
And what times what would give you 1?
Wait, so why don't you, why would you separate one? Like, how can you separate one for?
What times what would give you 1? 1 and 1. Can we factor any of these again?
No.
Yeah, the 4. The 4W squared minus 1. What 2 factors would that be?
2
W.
minus minus 1. Yeah.
So you do it again?
And that's your.
That would be our answer, because we cannot factor any of those again.
Why do you put 4W squared plus 1?
That one we cannot factor, and it was part of this original. Because it's plus, it's not difference of squares.
Yes.
Lily.
Okay, so there's 3 of them. What's the 3 of them?
3 of.
The 2 W's and this one.
So these 2 came from this one.
Yeah.
This one was this one.
Okay.
And this was this. So you have to completely factor it. If you don't, you may miss points.
So we can only do the, if it's a minus and the plus.
Great, we cannot do plus.
I have a question. If you're gonna put that without the 4W squared plus 1, what would you give us?
That would depend on how many points this is. Let's say I just put points to this. I would give you a point for factoring out the GCF, 1 point for each of these, 1 point for each of these. So 1, 2, 3, 4. You would lose 1 point to 3.
So like, would you guys give us?
It wouldn't be 1 point per question because there's multiple parts. So you would lose a point. Okay. Other questions on 5? Okay. Number 6. we have three terms, but we have two different variables. So first, look for GCF. 3xy.
3xy.
You could also divide each one by 3 by x and y. So if we do that, what would we left?
I think 2xy.
Not x, just y.
Oh yeah. And
Plus 1.
Plus 1. Now if we look at this trinomial, the first term is not squared and it still has two different variables. So we could not factor this anymore. The only way we can factor trinomials is if the first term has a square term and we only have one variable. If that is not the same, then we cannot factor.
So that's the answer.
So that would be the answer.
So is the GCF usually the last?
GCF is usually the first thing you do.
But why is it 3xy?
If I were to list out all of the factors for each of these, 24, what are the factors? 3, 4, 12. I think
3.
yeah, we got that one. 4, 6. Factors of 6. And then factors of 3.
I got the question.
So the highest number these each share is 3. If I look at each of the variables, they each have at least one x and they each have at least one y. So that's why 3xy is interesting.
Can you repeat why?
Factor it more.
Because it doesn't have an x first.
When we factor only when it has a square term first and only one variable throughout.
Wait, so can it be any x or does it have to be squared?
Squared. If it's not squared, you could probably factor out a variable.
What happens if it has a different x?
Like 3 or something higher, then you would. There's probably a GCF where you factor that out.
Are you going to have a question like that on the quiz?
I do not remember. I mean that's.
What do you mean by one variable? Like one.
This one has an x and a y. It would have to only be x's or only be y's or only be p, whatever the variable is. Other questions on 6? Or 7. This is a trinomial, but my first term has to the 4th. So does this have a GCF?
Yes.
If we divide that out, what's left? 2x squared minus x. For the inside, we do not have a GCF.
So that would be.
So that would be a does not equal 1 trinomial.
Can you even like find one that is plus?
Because remember with this, we're multiplying 2 and negative 6.
Oh wait, 3.
I do not. You can write this down. So multiply 2 and negative 6 to get negative 12. And we're looking for two factors that multiply to be negative 12, but add to be negative 1.
Is it negative 12?
The first number is negative 12, yes.
Negative 12 and 1.
Would that add to be negative 1? No.
Oh, wouldn't it just be like 13?
Is it negative 12 and
It has to multiply to be 12, but add to be negative 1. Think about the factors of 12.
Or negative 3.
What?
Opposite way though. Negative 4 and positive 3.
We don't know when this thing is gonna end by, so we have to go forward.
Yes, we're gonna -4, yes.
I think I'll just.
Like, it's at -4.
-4, +3. To bring down your GCF, rewrite this as 4 terms. 2x squared minus 4x plus 3x minus 6.
Okay, well, I did not do that correctly. I thought I was doing something correctly.
If you put plus 3x then minus 4x, that's fine. That order doesn't matter, just everything else has to be the same.
Then we split it down the middle.
Split down the middle, bring down your GCF. What do these first two have in common? 2x. What would be left?
X minus 2.
Minus 2. What can we divide out of these last two?
3 and inside X minus 2.
Then our last step, we have to rewrite all of this as final answers.
Wait, can we scroll back?
X minus 2.
The 4x squared has to go in front.
Are we doing number 9?
No, we're not. Not unless someone wants us to. And then 2x plus 3 at the end. Or these could be switched. Can we factor any of these again?
We're already on the same problem. Okay.
No, we're not.
No, we're not doing 9. I just put it there. I ran out of space.
Oh.
Oh. Okay.
Do we have any questions on that one?
Oh, I see what you mean.
Are you gonna take a point off with like 1 parentheses?
Wait, why do we have the double parentheses?
Because like,
This entire thing is all in parentheses already, and we had individual parentheses too.
And do we have brackets or no?
Sure.
Oh, okay.
so like if you miss like that second parentheses, are you gonna take a point off?
Because I often don't put it sometimes. Other questions on that? Number 8. Does this have a GCF? 4. If we divide out 4, what's that? 16x squared minus y squared. Could we factor this inside again?
Yes.
Using what?
Different squares.
Different squares. So bring down your 4. What would our 2 factors be?
X.
4x squared, not squared.
4x minus 4 plus 4y.
4x plus y, 4x minus y should be your answer. Can we factor either of these again?
Yes.
Yes, I want to.
Wait, no, because it doesn't have to.
Doesn't have squares.
Yeah.
Wait, what did you divide the 16x squared minus y?
What times what will give you 16? What times what will give you x squared? What times what will give you y squared?
It doesn't matter with the minus and plus.
Which order it goes in? No.
So you just divide the.
Not divide. You're looking for what times what will give you that, or the square root of 16.
That's why it's called a difference.
What? In June? I need to get my stuff now because my father's far, far away.
I do remember that. Alright, do we have any other questions on this page or on the back of this page that we want to go through before we do the next objective?
Wait, are we doing unit 11 as well?
Today, we're only doing 10 today.
And next week we're doing all the review. Are we even doing a review for unit?
No, we're not doing a review for Unit 12. You'll just have your notes. Bella. 20. Any others? 14. That was
Number 14 is grouping.
14 is grouping, yes. 14 and 20, any others? Okay, we'll start with 14, then do 20. For 14, this is grouping, it has 4 terms.
Back in the second one.
Say that again.
Oh, you can subtract it.
Factor out a negative 1?
Yeah.
I think. So of the first 2, what could we take out there?
9x squared.
9x squared. What would be left?
Plus.
What could we divide out of the second 2?
Negative 1.
Minus 1, negative 1. What would be left?
X plus 1.
X plus y. And then our 2 factors from this would be what?
X plus.
Does not matter the order. 9x squared minus 1 and x plus y. Can we factor either of these again?
1 plus 9x squared, and you would just make it like, you would switch the negative 1 and positive 1.
What would this factor be? 3x.
3x minus 1. And that would be the minus.
Yes, because we cannot factor that again. Oops.
If it were positive, could we still factor it again?
No.
Okay.
If it were 9x squared plus 1, we could not do this. It only works with difference, subtracting.
I am not gonna.
I'm more worried about unit 11.
For number 20, does this have a GCF? No. How else could we factor this?
9, negative 9.
Difference of
Squares
squares.
of squares. What would those 2 factors be?
10 minus 3y and 10 plus 3y.
Can we factor either of those again?
No.
That's it.
Wow.
Okay, so you will need to be able to determine what type of factoring you need to use for each of the factoring problems. On the next page, dividing polynomials.
We're combining it now.
Oh.
Subtracting X.
My girlfriend got
89.
no, she got 86 for SOL. Which is easy for her. But she's
Alright, for dividing polynomials by a binomial, we have to first factor the numerator and then see if we have like factors and then cancel out the like factors. How can we factor this numerator?
By trinomial.
Trinomial, and it's the basic for a equals 1 because there's nothing in front of the x squared. So we're looking for 2 numbers that multiply to be 21, but add or subtract to be negative 10. If they're both negative, yes. So negative 7, negative 3. So because this is a equals 1, we can go right into our factors. X minus 7, x minus 3, all over x minus 7. Do we have like factors?
No.
Yes, the x minus 7, so those would cancel, and you'd be left with just x minus 3.
That's the answer.
That is our answer.
Oh, that's it. I'm not saying that should be saying.
I mean, these are all basically. I am going to show you that the same trick we did in Desmos you can use on the calculator. Peyton, go ahead. So in my calculator, I'm going to go into my y equals and I'm going to type this equation.
You're doing a semi-equation.
Say that again.
We're this notation?
Yes, the fraction. So I'm gonna make this a fraction first. And then type in this entire thing. X squared minus 10x plus 21 all over x minus 7. And then I'm going to hit graph. And it's going to give me a line. And if you could count the slope of this line and find the y-intercept, then that would tell me this is x minus 30.
Oh.
I could also put in the answer I got, the x minus 3. Now for you guys, it would be just a black line. Mine would be colorful. But you could change the height of line to make it thinner or thicker, dotted, dashed, whatever. And you could see it like that. If I put in x minus 3, and then I graph them both, and you'll see that they graph over top of each other. Now, you still would have to show your work, so this is more of a check method. You can use this method, but this shouldn't be your only method.
Is there going to be multiple choices?
For this section, I don't remember. I know this section has less questions than the factoring. Yeah, before you guys leave, I will look at it.
Can you just like look to like where it intersects and ask your answer?
Both lines should lie over top of each other. Do we have any questions on one? For number 3, how would we factor this numerator? Squares, so what would those two factors be?
Y plus 5, y minus 5.
All over y plus 5. What would our final answer be?
Y minus 5.
Y minus 5. We use difference of squares here to get what times what would give us y, what times what would give us 25, so a plus and a minus.
So it's gonna be
For the final answer, you mean? No.
Depends on what's.
Yeah, it depends. Because if there's a plus, it also depends on the factors. So no.
Why are there two y plus 5?
One was already in the problem, and then we factored the numerator to get the other. Are there questions on that one? Yes. Yes. On number 4, how should we factor this numerator? GCF. What would the GCF be? 2x. If we divide out 2x, what's left? X plus 8 all over x plus 8. What would our final answer be?
2x.
2x.
I mean, I kind of understand like the process to get it, but I don't understand like getting it to the thing itself.
Got it.
Thank you.
So like, you do x squared.
As the answer?
No, okay, so 2x squared plus 16x. I don't understand how we got 2x in parentheses x plus 8.
We look for what these two have in common, which is we could divide both of these by 2, and these both have at least one x. So your GCF is 2x,
Okay.
and you're dividing both of these by 2x. And what would be left is x plus 8.
Okay.
John,
No, I got it.
as soon as Kayla gets back.
How come it's not like an x minus 8x plus?
Not different than squares.
Why are
Is it
Who designed
is it because they both have x or a fact or a variable?
If this had minus and this had minus, that would be different. But we didn't factor out a negative. For number 5, how would we factor this numerator?
Like this much after what that was.
We are going to use the x, the trinomial.
Yeah.
Does this have a GCF? No. So then we're looking for two numbers that multiply to be 2 times negative 12. So negative 24, but add to be 5.
It's 8 and minus 3.
Yes. Okay, so for this one, you have to write a little bit more because there's more steps. So if you need to extend it somewhere else, or if you get a problem like this and you need more paper or more space, just get more paper. So let's rewrite it first. 2x squared plus 8x minus 3x minus 12. Split the middle. What do these first two have in common? 2x. What would be left when we divide it?
X plus 4.
X plus 4. What could we divide out of these last two? Negative 3. And what would be left? 1x. And
Minus 4.
plus 4, because you're dividing out a negative already. And then your final factors would be what?
2x minus 3.
So your answer is x plus 4. What questions do we have on that one? Bless you. Okay, we're going to do one more of these unless anyone wants to see any others. Is anyone still writing this one down? On the back of this same page, we're going to do number 15.
Oh, that's all.
So if you want to, you can rewrite this as a vertical fraction instead of writing it horizontally. Either or, does not matter. I think I'm going to do that at the end. How would we factor this?
We split it.
Yes, because it's 4 terms, so we're going to factor by grouping. So what do these first two have in common?
X squared.
X squared. What would be left?
X minus y.
What do the next two have in common?
6.
Negative 6, because this one is negative. Whatever this sign is, that's what you should bring down. What would be left?
X plus y. Minus y.
Minus 1. Okay, so we have x squared minus 6, x minus y, all over x minus y. What would our final answer be?
X squared.
X squared minus 6. If this said x squared minus 9 or some perfect square, then we could factor it again, but this did not say that, so we don't have to do that. On this or the back, do we have any other questions we want to go over or see? Any other? For number 2, how would we factor this numerator?
Trinomial.
Basic trinomial or a equals 1. So we're looking for two numbers that multiply to be negative 45, but add to be negative 4. With these, this is nice because this gives you one of the numbers. It has to be a negative 9. Negative 9 has to be one of your numbers.
5.
So 5. So if you're not sure about the factors, and it's a trinomial, you can look at the denominator to help you. Now if it's something like this, that may not help you. Okay, so then our two factors would be m minus 9, m plus 5, all over m minus 9. What would our final answer be?
M plus 5.
M plus 5.
What happened to the 45?
We split that into negative 9 and 5. Any other questions?
I thought you were supposed to lay it out.
That's if we have a number in front of the x squared, or that square term. This is an a equals 1 trinomial, so we don't have to do that. For the remainder of class, you're going to go through all of these problems. I would say try different types of factoring, try different types of dividing polynomials with different factoring methods, and practice those. Let me know if you need my help, want me to check over anything, have any questions. You guys can work together, but use this time to practice.